Hi guys, if you're someone who's looking for the IGCSE Cambridge paper code 0580 May June 2024 marking schemes, then you're at the right place because I have the solutions right over here. So let's go. And the first question says a diagram shows two sides of parallelogram ABCD. Find the coordinates of D. So to find the coordinates of D, let's start walking horizontally from point B towards C. So that's 1, 2, 3, 4. And then vertically, it's going to be 1, 2. So 4 units over here and 2 units over here. I'm going to repeat the same pattern from point A. So that's 1, 2, 3, 4, 1, 2. As you can see, if we join the points, we can clearly see that we have a parallelogram. And this is the coordinate of D, which is going to be -3 and 7. Question number 2 says, Geeta has a box of toys. She picks a toy at random from the box. The probability that she picks a wooden toy is 0.6. Work out the probability that she does not pick a wooden toy. So if the probability of picking a wooden toy from box is 0.6, the probability of not being able to pick a wooden toy is going to be 1 minus 0.6, which is 0.4. Part B says the box contains 3 types of toys: wooden, plastic, or metal. We have to find the number of toys for wooden and the probability for plastic and metal. So we know that the probability of the entire box with all of the different toys is 1. So the probability of getting a wooden toy is 0.6, and the number of plastic and metal toys is the same, which means the 0.4 probability gets divided into plastic and metal. So that's going to be 0.2 and 0.2. If the number of plastic and metal toys were different, then the probabilities would be different. But since the number of toys is same for both plastic and metal, hence the probability is also going to be equal, which is going to be 0.2 and 0.2. Now, talking about the number of wooden toys, we can easily find the total number of toys first by using 14 over x equal to 0.2. Now, x is your total toys, and the probability of finding, let's say, plastic toys is 0.2. So 0.2 is basically 14, which is number of plastic toys, divided by the total number of toys, which is x. So to find x, we do 14 divided by 0.2, and that gives us 70. So 70 is the total number of toys. So to find the remaining number of wooden toys, we will subtract 14 from 70. So since plastic is also 14 and metal is also 14, so it's going to be 70 minus 14 minus 14, which is 42. So that is your final answer. Question 3 says, the table shows some information about two sequences. There's a sequence A and there's a sequence B. We have the nth term for both the sequences, and they want us to find the fifth term. So substitute n as 5, 60 minus 4 times 5, which is equal to 40, and 5 squared minus 300, which is equal to negative 275. So that is your answer. Part B says find the smallest positive number in sequence B. So for smallest positive number, the n square value has to be greater than 300. So for this, you'll just have to use trial and error. You'll have to use different numbers and square them to see which one gives a value greater than 300. So if I start with 15 squared. Now 15 squared is 225. 225 minus 300 will be negative. So let's go with 17 squared. That's 289, again less than 300. So let's check for 18 squared. Now 18 squared is equal to 324, which is greater than 300. So if we do 18 square minus 300, that's basically 324 minus 300. And that gives us 24. This is the smallest positive number in the sequence. If we keep on increasing the value of n, our value of the positive number in the sequence will also keep on increasing. Because 19 square is obviously going to be greater than 18 square. And we subtract 19 square from 300, we will get a greater positive number. Hence, the smallest positive number in sequence B is 24. Question 4 says find the greatest odd number that is a factor of 140 and 210. So if we break down 140 into its factors, that's 14 times 10. 14 is 2 times 7 and 10 is 2 times 5. For 210, that's 21 times 10. 21 is 3 times 7 and 10 is 2 times 5. As you can see, 2, 7, 5, and 3, these are all prime numbers. So we can't further break them down. So since we can't further break them down, we're going to highlight the ones that are common over here. So we're going to highlight the odd numbers that are common over here. So we have 7 and 5 over here, and 7 and 5 over here. Since 3 is not present in 140, so we can't take that common as the odd factor. Hence, the factor is going to be 7 times 5, which is 35. So this is your greatest odd number factor that is common between 140 and 210. Question 5 says calculate cube root of 344. Cube root of 343 minus square root of 40.96. So for this, you just plug this in the calculator. And what you'll get is 7 minus 6.4, which is basically 0.6. Then for part B, it says 192 plus 4 times 16, whole power 1.25. So in this case, we're going to follow the rules of BODMAS. Brackets first, then indices, then division, multiplication, addition, subtraction. So since we're going to solve the brackets first, we can see that inside the brackets, we have multiplication and addition. So I'm going to do multiplication first. So 192 plus 4 times 16, which is 64. Now we do 192 plus 64, which is basically equal to 256. Now 256 to the power of 1.25 is going to give you 1024. So that is your answer. Question 6 says, the diagram shows 5 kites that are congruent to kite ABCD. Each kite is joined to the next kite along one edge. Angle DAB is 40 degrees. DCE is a straight line. Find the value of x. So since they're congruent, that means all of these angles are 40. And let's say all of these are y. Why? Because like, firstly, the congruent kites, that means the angles are going to be the same. And since DCE is forming a straight line, we can add up all of these angles and put that equal to 180 to find the value of y. So 180 is going to equal to 6y because there are 6, 1, 2, 3, 4, 5, 6 kites. So 180 divided by 6, which is basically 30 degrees. Now 30 degrees is the value of y. Now what we can do is that, just erase this first. So 30, 30, 30, all of these are 30. Now, a very common property of the kite is that these two angles are equal. So if these two angles are equal, so that means this is also going to equal to this. So to find these angles, we can easily put the sum of these angles equal to 360. Why? because kite is a quadrilateral. And for a quadrilateral, the sum of angles is always equal to 360. So 360 equals to 40 plus 30 plus x and x. Why? Because this is x, so this is also going to be x. So that's 360 equals to 70 plus 2x. Subtract 70 from 360, which is basically going to give us 290. So now 290 divided by 2 is 145. So 145 degrees is the value of x. Question 7 says the diagram shows a shape made from a triangle JKL and a semicircle with diameter JL. JKL is an isosceles right angle triangle with JK equals to JL equals to 12.8 centimeters. Calculate the area of the shape. So as you can see, we have a semicircle and a triangle joint. So area 1, which is going to be the area of semicircle, that's going to be pi r square over 2. Since the diameter is 12.8, radius is going to be 6.4 centimeters, which is half of the diameter. So that's going to be pi times 6.4 square over 2. When you plug that in the calculator, what you should get is 64.34 centimeters squared. Area 2 is going to be your area of triangle. Now to find the area of the triangle, the formula that we're going to use is 1 over 2 times base times height. JK is your height and JL is your base. So that's going to be 1 over 2 times 12.8 times 12.8, and that is going to give you 81.92 centimeters square. So now to find the total area of this composite shape, we'll add up area 1 and area 2. So that's 64.34 plus 81.92, and that equals to 146.26 centimeters square. That is your answer. Then the second part they're asking us to find the perimeter of this shape. So to find the perimeter, we need to find the circumference of the semicircle and the length of JK and KL. Length of JK is already given, so we need to find the length of KL. Now, as you can see, it's a right angle triangle, but two lengths are equal, which makes it a isosceles right angle triangle. So if this is equal to this is going to equal to this. And if you remember the special right triangles property, if you have an isosceles right angle triangle, the length comes in the ratio of 1 is to 1 is to root 2, which is for 45 is to 45 is to 90. This is the ratio for angle. This is the ratio for lengths. So since we have 12.8 for 1, so it's going to be 12.8 ratio 12.8 ratio 12.8 root 2. So this is our length of KL. So let's begin with finding the circumference. Circumference is going to be pi r. Why pi r? Because circumference of a circle is 2 pi r. So 2 pi r divided by 2 is pi r. So pi times 6.4, and that equals to 20.11 centimeters. Now for the perimeter, we will just add 20.11 to 12.8 and 12.8 root 2. JL, the curve length JL, JK, and KL, all these three are being added. So that is going to give us 51.01 centimeter as the perimeter. Question 8 says that these are the first 5 terms of a sequence. Find an expression for the nth term of the sequence. So whenever we have a sequence, let's first start with finding the common difference. Between 18 and 11, we're adding 7. Between 25 and 18, we're once again adding 7. And same over here, we're adding 7 between each consecutive term. So this shows that we have a common difference of 7. So whenever we're trying to find the nth term of any sequence, especially a linear one, always start with finding the common difference. And once you've done that, multiply the common difference by n. So that's going to be 7n over here. If the common difference was being subtracted, like from the second term, so then you would make it negative 7n. But since it's being added to each consecutive term, so it's positive 7n. So now let's assume that the nth term is 7n. So if we find the first term using 7n, 7 times 1 gives us 7, not 11, which means we need to add 4 to make it 11. Now let's use the 7n plus 4 formula to find the next term. So 7 times 2 plus 4, that's 14 plus 4, and that is 18, which matches with the sequence. If we try to find the fourth term, 7 times 4 plus 4, that's 28 plus 4, and that is 32. Which is again the same as the term in the sequence, which means the nth term is 7n plus 4. Always recheck with your numbers in the sequence, and if they're matching with the ones that you're getting, your nth term is probably correct. Question 9 says the value of a car is $8,000. Each year, the value of the car decreases exponentially by 25%. Calculate the value of this car after 3 years. So value is 8,000 initially. It decreases exponentially by 25% after every 3 years. So we're going to do 8,000, which is the value of the car, times 1 minus 0.25 to the power of 3. So for exponential increase or decrease, if it's exponential increase, your formula will be your initial value times 1 plus the rate at which it's decreasing or increasing to the power of 10. If it's decrease, then you subtract it. So 1 minus r over 100 whole power t. So t is your time, r is your rate, and I is your initial investment. In our case, since it's an exponential decrease, so it's 1 minus 0.25. And that's basically 8,000 times 0.75 to the power of 3. So that should equal to $3,375. Question 10 says, Mir invests $1,500 in an account. The account pays compound interest at a rate of R% per year. At the end of 8 years, the value of his investment is $1,656.73. We need to find the value of R. So to define the value of R, what we're going to do is that use the compound interest formula. So compound interest formula is your principal amount or your initial investment multiplied by 1 plus R over 100 to the power of time. So our final investment is 1,656.73, which equals to the initial amount 1,500 times 1 plus R over 100 to the power of 8, because we're looking at the investment after 8 years. So first we divide 1,656.73 by 1,500. And that's going to give us 1.104486. Next, what we're going to do is that we're going to take the 8th root on both sides to get rid of the 8 on this bracket. So for the 8th root, we will get 1.0125 equals to 1 plus r over 100. As you can see now, the 8 on top of the bracket is gone because when you're taking a root, for example, 8th root basically means the power of 1 over 8. So if we multiply 1 over 8 power times 8 power, that equals to 1. But similar with cube root. Cube root is the power of 1 over 3. Square root is the power of 1 over 2. So this is how we take roots to get rid of powers on top of like expressions that we want to further simplify. So 1.0125 equals to 1 plus r over 100. We take the 1 to the other side. So it's minus now. So that's 0.0125 equals to r over 100 times 0.0125 by 100. And your final answer is going to be 1.25%. So that's your rate of trust. Question 11 says, find the inequalities that define the unshaded region R. So whenever you have a dotted line, always remember it's either less than or greater than. And if you have a straight line with like, completely filled one, that basically means it's either greater than equal to or less than equal to. Which means for this line at x equals to 6, we're looking at the region that's less than it. So that's going to be x is less than 6. For the line drawn at y equals to 1 and y equals to 5, for y equals to 1, it's looking at the region greater than y equals to 1. And for y equals to 5, it's looking at the region less than 5. So y is less than equal to 5, but greater than equal to 1. Lastly, we have this diagonal, which is also a dotted line, which means it's either going to be less than or greater than. So if you notice, for x equals to 2, it's y equals to 2. For x equals to 3, it's y equals to 3, and so on, which means it's y equals to x line. But for the region, it's looking at the values of y that are decreasing, not increasing, because this part is what we're focusing on. So it's going to be y less than x. These are your 3 inequalities that define the unshaded region R. Question 12 says, solve the simultaneous equations. You must show all your working. So first thing first, begin with trying to get rid of the fraction in the equation so that your equation is easier to solve. So to get rid of this fraction, I'm going to multiply the first equation by 2. That's going to give us 3x plus 10y equals to 10. And the other equation is 4x minus 3y equals to 46. Now, in order to solve this simultaneous equation set, I'm going to use elimination method. For elimination method, we need to first decide which variable we want to eliminate. I want to eliminate x. So to eliminate x, I need to make sure that the coefficients of x are equal in both the equations. As you can see over here, the coefficient of x is 3, and here it's 4. So to get rid of x, we need to multiply the first equation by 4 and the second equation by 3. So that's going to give us 12x plus 40y equals to 40. And then 12x minus 9y equal to 138. So now as you can see, both the coefficients of x are equal. We can eliminate these two variables by subtracting the equations. Why are we subtracting? The reason why we're subtracting is because 12x is positive in the first equation and positive in the second equation as well. If we added the two equations, that would give us 24x. So x isn't going anywhere. So in order to get rid of x, we need to subtract the two equations. So that's going to give us 12x minus 12x is 0. 40y minus negative y is positive 49y. 40 minus 138 is going to be negative 98. So y is negative 98 divided by 49, and that equals to negative 2. So y is negative 2. Find the corresponding value of x. You can put y equals to negative 2 in either of the equations. There is no restriction that you have to put it on the new equations or the old ones. You can use any equation. So I'm going to use this one because that's easy to solve, like the numbers are smaller. So 3 over 2x plus 5 times negative 2 equals to 5. So that's 3 over 2x minus 10 equals to 5. 3 over 2x equals to 5 plus 10, which is 15. 3x is 15 times 2, which is 30. Hence, x is going to be 30 divided by 3, and that is 10. So when x equals to 10, y is negative 2. And that is your answer. Question 13 says, the diagram shows a cyclic quadrilateral. Find the value of p. So to find the value of p, you need to remember a very important property for cyclic quadrilaterals. In a cyclic quadrilateral, firstly, all of your vertices need to touch the circumference of a circle. And as you can see, all 4 vertices are touching the circumference, which means, yes, this is a cyclic quadrilateral. Secondly, in a cyclic quadrilateral, opposite angles add up to 180. So if I call this A, B, C, and D, angle A plus angle C is 180. And angle B plus angle D is also equal to 180. So using these two properties, we can figure out what the value of M and P are. So A is basically 4M and C is 5M. So that's 9M equals to 180. So M is 180 divided by 9, and that's 20 degrees. That's 20. Now for B, that's P plus 4M plus 38 equals to 180. Now that we know what M is, we can substitute the value over here and find the value of P. So that's P plus 80 plus 38 equals to 180. P plus 118 equals to 180. We subtract 118 from 180, and that should give us 62 degrees as the value of P. And that's your answer. Question 14 says, the diagram shows a circle with radius n centimeters. Calculate the area of the shaded major sector. Keyword over here is shaded major sector. So we calculate the area of this part, not this. This. So to do that, we need to find the angle for this sector. And to find the angle of this sector, we will subtract 48 from 360, which is basically equal to 312. So now 312 is our angle. Next, we need to know is the formula of sector. So area of sector is basically theta over 360 times pi r square. So that's 312 over 360 times pi, and r square is 9 square, which is the radius. So when you plug this in the calculator, what you should get is 220.54 centimeter square. That is your area of the shaded major sector. Question 15 says, Write 0.146 recurring as a fraction in simplest form. You must show all your working. So these kind of questions are like very common, and if you know how to solve it, like the trick, then you don't need to like get scared by it. So 0.146 recurring basically is this 0.146. Your 4, 6 are the recurring numbers. So if you know the steps, you're good to go for this question. First step is to assume that x equals to 0.146 recurring. And then multiply x with like 10, 100, or 1000 based on like what you want to create. I'm going to multiply this by 1000 first. When I multiply x by 1000, that basically gives me 146.46, and so on. Now, the goal for you is that you need to get rid of these numbers after the decimal. So you need to make sure that whatever you're multiplying x by, whether it's 10, 100, and 1000, you multiply it twice. And both times you need to make sure that the numbers after the decimal are same. So that when you subtract the two, the decimal numbers get removed. So what I'm going to do is, I'm going to multiply x by 10 now. Why? Because when you multiply x by 10, that gives me 1.46. And so on. So as you can see, after the decimal, we have 4646 for both the 1000x and 10x. You can multiply it by 10,000, 100,000, and so on. There's no restriction on that. But you need to make sure that you're choosing like easier numbers so that your calculation is easier. And when you're simplifying the fraction, it doesn't take a long time. So now I'm going to subtract 10x from 10,000 from 1000x. And over here, it's going to be 146.46 minus 1.46. So that's 990x. And over here, the decimal numbers get removed and we're left with 145. Simple as that. Now you just make x the subject by dividing 145 by 990. Simplify the fraction, and that gives you 29 over 198. So if you know these steps, like the number that you're trying to eliminate, making sure that the numbers after the decimal are equal so that when you subtract the two, you get rid of the numbers, you're golden, like you don't need to worry about anything. So 29 over 198 is your answer in its simplest form. Question 16 says in the Venn diagram, shade the region M complement intersection N complement, which is basically equal to M union N whole complement. So M union N whole complement is going to be everything outside of M and N. Simple as that. Then find the number of B intersection A complement union C. So A complement union C is basically going to be all of this. And that has to be in intersection with B. So B is going to be this, this, and this. 10 plus 4 plus 3, which is equal to 17. So 17 is the number of values which are a part of A complement union C intersection B. Question 17 says calculate the area of this triangle ABC. So as you can see, in the previous case, we had a right angle triangle. So when you have a right angle triangle, you can easily use the formula 1 over 2 times base times height. But when it's a non-right angle triangle, we have a different formula. So area of non-right angle triangle. So that's basically 1 over 2 times AB sine of angle C. In our case, it's going to be 1 over 2 times C times A times sine of angle B. For you to use this formula, the condition is that you need two lengths and the angle between them. So two lengths and the angle between them. If you don't have two lengths and the angle between them, then you cannot use this area of triangle formula. But if you do have it, you can easily use this and find your area. So it's going to be 1 over 2 times 6.7 times 5.9 times sine of angle 81. So when you plug this in the calculator, what you should get is 19.52 centimeters squared. And that's your answer. In the next question, it says, the diagram shows the graph of y equals to x cubed plus 4x squared minus 2 for the range of -3 to positive 1.5 for x. By drawing a suitable straight line, solve the equation x cubed plus 4x squared minus 2 equals to 2x for -3 to 1.5 for x. So if we compare the first equation to the new equation, we can see that the only difference is that it's equal to 2x, which means the second equation that we're going to sketch is for y equals to 2x. And that's also for the values from -3 to 1.5. So what I'm going to do is I'm going to make a small table of values for x and y. So x and y. So for x, I'm going to take -3, -1, 0, and 1.5. So when you substitute these values in this equation, y equals to 2 times -3 is -6. Y equals to 2 times -1 is -2. Y equals to 2 times 0 is 0. And y equals to 2 times 1.5 is basically 3. So now that we have our coordinates, we're going to plot them on this graph. -1 and -2, that's over here. 0, 0 is over here. And 1.5, 3 is over here. That is our line. It's gonna go ahead like till -3, but the issue is that we don't have, the axis is very small. Doesn't include -6, so I'm just plotting it till here for now. So they want us to find the intersection between these two graph and line. So for the intersection, we're going to draw a line from here to here and from here to here. So now for the intersection, we can see that x is -0.5 and x is 0.9. These are the two values of x that we get when the two intersect. Question 19 says, factorize completely 12m squared minus 75t squared. So between 12m squared and 75t squared, what we have is 3 common. So I take 3 common, that gives me 4m squared minus 25t squared. Now 4m squared minus 25t squared reminds me of difference of perfect squares. So in difference of perfect squares, the rule is that you subtract 2 perfect squares. And when you subtract 2 perfect squares, they can factorize into a minus b times a plus b. So let's say we had m squared minus 4. So 4 is also a square number, which is 2 square. So we can rewrite that as m minus 2 times m plus 2. So in our square, 4 is 2 square and 25 is 5 square. So that's going to be 3 times 2m minus 5t and 2m plus 5t. That's your final answer for this factorization. Part B says xy plus 15 plus 3y plus 5x. So in this case, we can't add or subtract any of these terms because all of them are unlike terms. So what we can do is we can rearrange them and write xy plus 3y plus 5x plus 15. So now, as you can see, we can factorize these terms, but by making two groups. This is one group, and this is the other group. If you look at the first group, we have y common. So that's going to give us x plus 3 in the bracket. And the second group, we have 5 common. So that's going to give us x plus 3 again in the second bracket. So between 1 and positive 5, we have x plus 3 common. And that is our fully factorized answer. Question 20 says, solve the equation 8 sine x plus 6 equal to 1, where x is between 0 and 360. So in this case, what we're going to do is we're going to make sine x the subject first. We do that by bringing positive 6 to the other side. So that's 8 sine x equals to negative 5. Then sine x is negative 5 over 8. So x is going to be sine inverse of negative 5 over 8. So when you find the inverse of that, that basically equals to negative 38.68. Now, this is not the final answer. There's still a few steps I need to do to figure out what the two values of x are, because x has to be between 0 to 360. And this is negative, which is completely out of the range. So to find the final answer, you need to know where sine is negative and positive. Sine is positive in the first two quadrants and negative in the last two quadrants. So negative 38.68 is going to come over here and over here. So now to figure out what the value is of x, we start measuring in anti-clockwise direction towards the angle line. So this entire angle is the first angle, which is going to be 180 plus 38.68. And the second angle is going to be 360 minus 38.68. Always remember that you're measuring your angle from the 0-degree line. You're going anti-clockwise towards the angle line. So for the first one, it's 180 plus 38.68. And for the second angle, it's 360 minus 38.68. So this is 218.68. And this one is 321.32. So these are the two angles which fall in the given range. Question 21 says that we have a diagram of a cuboid where we have the length of HT, EH, and EF. They want us to calculate the angle between CE and the base CDHG. So that's basically this angle over here. This is what we need to calculate. So over here, if you notice, we have a right angle triangle. And for this right angle triangle, in order to calculate the angle, we need one of the lengths. Either we need EC or HC. We already have EH. So what we're going to do is that we know this is 9.1, which means this is also 9.1. And this is also 9.1. So we can easily find CH. We can easily find CH using Pythagoras because it is also a right angle triangle. So CH equals to the square root of 4 square plus 9.1 square. So that's going to be square root of 98.81 and CH is going to equal to 9.94 centimeters. Now I'm going to draw another triangle over here so that it's easy for you to understand. This is your triangle EHC. CH is found as 9.94. EH is 6.5. We're trying to find this angle. So over here, we're going to use SOHCAHTOA now. So for SOHCAHTOA, we need to figure out what lengths we have. Do we have the opposite? Do we have the adjacent? Do we have the hypotenuse? What do we have? So adjacent is always the length on which your angle lies. So this is your adjacent. And the length that is opposite to the angle is called the opposite. And the diagonal is always the hypotenuse. So since we have the opposite and adjacent, we're going to use tangent because tan theta is opposite over adjacent. Using this ratio, we can see that we only have one unknown, which is the angle. So tan theta equals to 6.5 over 9.94. And that is going to give us tan inverse of 0.65392, which is basically equal to 33.2 degrees. That is your angle between CE and the base CDHG. Question 22 says, we have bag A and bag B. Each contain red counters and blue counters only. Stefan picks a counter at random from bag A and Jen picks a counter at random from bag B. The probability that Stefan picks a red counter is 0.4 and the probability that Stefan and Jen both pick a red counter is 0.25. Find the probability that Stefan and Jen both pick a blue counter. So we're going to draw a tree diagram over here. We have two people and we have two types of counters. This is for Stefan and this is for Jen. So we have red, blue, red, blue, red, and blue. So the probability that Stefan picks a red counter is 0.4, which means the probability of Stefan not picking the red counter is going to be 1 minus 0.4, which is 0.6. So this is 0.6. The probability that Stefan and Jen both pick a red counter, which is basically going from here to here, because both pick a red counter, that's 0.25, which means 0.25 is going to equal to 0.4 times x. X being probability of Jen picking a red counter. Now, the reason why I'm multiplying 0.5, 0.4 and x is because when you're moving along the branches, just from here to here, you multiply. When you're moving across the branches, you add. So since you're moving along the branches, 0.4 times x equals to 0.25. So 0.25 divided by 0.4 is going to give us the value of 0.625. Now they want us to find the probability that Stefan and Jen both pick a blue counter. So if this is 0.625, this one is going to be 1 minus 0.625, which is basically equal to 0.375. Right, so 1 minus 0.625, 0.375. So that means this is also 0.625 and this is also 0.375. So now we're talking about the probability of both picking a blue counter. So that's from here to here. So that clearly shows that we're going to multiply 0.6 and 0.375. So 0.6 times 0.375, and that is going to give us 0.225. This is your final answer.